Hi and welcome to Maths class. In this video we're looking at the distribution of the sample proportion, and this video is focusing on sampling from a small population. The next video will look at sampling from a large population. So what we're going to do is we're going to change our situation. You saw in the last video that I had in a cup I had some red and green trains. So this time what I've got is a cup that actually contains 4 green and 8 red trains, and I'm going to take a random sample of size 4, and I want to know what is the probability that there is 1 green train. Now we need to do a little bit of revision before we can answer that question. Actually, sorry, before I do the revision, we're going to think about this logically first, and then I'm going to take you through revising some concepts. So if I've got a random sample of size 4, then I'm looking for a probability of 1 green train. So there are 4 different ways that can happen. The green train could be first, or it could be second, could be third, or it could be fourth. Oops. Okay. So what's the probability of this happening? Now remember, this is sampling without replacement because I'm taking a sample of 4 distinct items. So I can't put it back and choose the same one again. So if the first thing I choose is green, there are 12 trains and 4 of them are green. So that's going to be 4/12. Now, I'm not going to simplify it because we're going to look for a pattern here, okay? Now, the next one I choose is red. There are now 11 trains left in my sample, and 8 of them are red. The next one I choose was also red. What's the probability of that happening? There are 10 trains left in my sample, and 7 of them are red because I've taken one out. And for my last train, there are now 9 left, and 6 of them are red. So the probability of that last red one was 6/9. Okay, red, green, red, red. What's the probability of it happening exactly like that? What I'm going to have, my first one is red. There are 12 trains in the cup, and 8 of them are red. So the probability that the first one is red is 8/12. The second train that I choose, what's the probability that it's green, given that I already chose a red train? There are 11 left in the cup, and 4 of them are green. My third one is going to be red. What's the probability of that happening? There are 10 trains left in the cup, and 7 of them are red, and the last one again is going to be 6/9. Okay, probability of getting red, red, green, red. Let's have a look at that. So again, the first one I choose is 8/12. Now I'm going to choose another one. What's the probability that it's red, given that my first one was red? Well, there are 7 red left out of a total of 11 trains. The next one is green. There are 4 trains left out of a total, 4 green trains in the cup. I haven't chosen any yet. I have a total of 10 trains left in the cup. And finally, there are 6 red left out of a total of 9 left. And in the same way, I'll just do the last one quickly. It's going to go 8/12 times 7/11 times, this time it's going to be 6/10. And the last one is the green one, 4/9. Now, hopefully you've seen a pattern. My numerator is 4 by 8 by 7 by 6 each time, just in different orders. And my denominator each time is 12 by 8 by 10 by 9. So when I add all of those together, the probability of having 1 green, I just did it on my calculator. Oh, here it is, 224 over 495. You definitely don't want to do that by hand. Okay, that's one way of doing it. But we also want to do a little bit of revision because there is another way of doing it. And if we've got a lot of these to calculate, we do want something a little bit faster. So what I'm going to remind you of is this. Or you might have seen it written like this. N choose X. This is the combinatorics. Okay, so what I'm saying here is the number of ways of choosing X items from a total of N. So a simple example of that is there are 4 green and I'm choosing 1 green. In this sample, I'm choosing 1. So how many different ways can that happen? Okay, I'm going to multiply that by, there are 8 red and I want 3 of them, 3 in my sample to be red. Okay, and I'm going to divide that by, there are a total of 12 trains and I'm choosing 4. So this bottom denominator here is a way of writing how many different ways can I choose 4 items if I've got 12 in total. So my denominator is going to be the total number of possible combinations if I choose 4 trains from this cup. My numerator, this is all the different ways that my 3 red trains can be chosen. There are a total of 8 trains. I only want 3 of them in my sample. And this part here tells me the total number of ways of choosing 1 green from a total of 4 greens. Okay. If I put that into my CAS calculator, I get the exact same answer. I'm going to show you how that looks. Let's open up my CAS again. Where are you, CAS? Here it comes. So I go into main. Don't need that. And what I'm going to do is I'm going to open up my keyboard and I'm going to go down. I'm not going to my catalog. I'm going to advance. And here, right over on the right, you can see NCR. So I want to do 4, choose 1. So I just go 4, 1, close my bracket. I'm going to multiply that by 8, choose 3. 8, choose 3. And then I'm going to divide that. My denominator is 12, choose 4. So that's 12, choose 4. And I want a fraction, hit enter. I get 224 over 495. Same answer as I got using this other method. So we're going to use this technique for calculating our probabilities for the following slide. Okay, so what I've done so far is I've worked out the probability of 1 green train. So let's just go to the next page. And what I've got here now is a distribution. If I take a sample of size 4, I might get no green trains. I might get 1, I might get 2, I might get 3, and I might get 4. And I just worked out that the probability of getting 1 was 224 over 495. That means the probability of getting a sample where the proportion is 1/4, because out of a total of 4 in my sample, 1 of them is green. Okay. Now, this is going to give me 0. This is going to give me a half, 2 out of 4. This will give me 3 out of 4, and this will give me 1. This is p hat, the proportion of green trains in the sample. And what I'm going to do now is, using the same method, I'm going to fill in all of those probabilities. So I'm going to use the same method that I used before. And so, for example, if I'm looking for the probability that p hat is equal to 0, that's going to be, using the same formula, I've got 4 green trains and I'm going to choose none of them. and then 8 red, and I'm going to choose 4 of them, divided by a total of 12 trains, and I need to choose 4 for my sample. And I did that one already, and it gives me 14 over 99. So I pop that in here, 14 over 99. I can do the same for when I've got 2 here, and of course I'm going to do this in my CAS, and the easy thing about that is I can just go and edit the numbers. So when I'm doing the probability that p hat is 1/2, I'm really looking at 4 choose 2, I'm looking at 8 choose 2, and I've got 12 choose 4, and that is going to give me, and I get 56 over 165. Okay, so I'm going to do each of those in that way. 56 over 165 goes here, and 32 over 495, and finally 1 over 495, because that's basically so one thing to notice is that if I add up all my probabilities here, then they're all I'm going to get a sum of 1. So if I'm ever doing one of these and I want a way to check my answers, if I add up all these fractions, I should get 1. And I have checked that. They do add up to 1. And so what I've got here looks very much like the distributions that we've been seeing before. Here I've got my my discrete variable x, which is the number of something, in this case the number of green trains in my sample. And here I've got p hat. So what we get then is the proportion distribution, which looks like this. The value of p hat could be 0, 1/4, 1/2, 3/4, or 1. And then I've got the probability that capital P hat equals small p hat. And these are my probabilities. So this is the sampling distribution for this particular sample that I could be taking. And so here's a new question then. What is the probability that the proportion of green trains in the sample is less than 1/2? I can calculate that. The probability that P hat is less than 1/2. Well, here's 1/2, but I want less than that. So I'm going to be adding up the probability that P hat equals 0 plus the probability that P hat equals 1/4. Now this looks very familiar. What's different here is this is not a discrete random variable, because discrete random variables have whole number values. These are not whole number values. In fact, P hat is always going to be a number between 0 and 1. Okay, let's add it up. 14 over 99 plus 224 over 495. Throw it into your CAS. I did this one earlier. 294 over 495. Okay, so in the next video, we're going to be looking at sampling from a large population. I want to point out sampling from a small population, what makes that specific, the reason we need this technique is because of what happens here. I've got sampling here, I'll just jot it down here, sampling without replacement. Okay, in a small population such as this, if I pull out a green train, then that is going to significantly change the probability of either red or green for the next one that I pick out, because I'm not putting it back when I'm making a sample, right? I'm collecting a sample of 4 distinct trains. I don't put them back first. So it's sampling without replacement. When I have a very large population, such as all the adults in Australia, for example, choosing one out of my population is not going to affect the probability. So the way we work out probabilities is going to be quite different, and that's in our next video.